Hello, my name is Joshua Ott. This is my final project report video for my Active Control Windmill project. I will give a brief overview of its control system as well as a full demonstration of all of its functions. Here's a basic control diagram for my project. At the heart of it is an Arduino Uno. It is connected to a Hall effect analog position sensor as well as a small stepper motor that comes in the standard Arduino kit. The design of the physical body allows the windmill blade assembly to tilt horizontally in both directions. Whenever the wind is no longer centered on the windmill assembly, it tilts the assembly. The Hall effect sensor reads that, passes that information to the Arduino. The Arduino calculates the motor movement, and then the stepper rotates the windmill body until that windmill blade assembly is centered. Here's the Arduino sketch that controls the whole project. The beginning is pretty standard, library inclusions, definitions, initializations, as well as the setup. In the operational portion of the sketch, I used an interrupt service routine and attached the sensor input to that so that the computational part of the program always has updated information. However, I framed that computational part so that it could actually complete the computations, create the output, without being interrupted. After that, interrupts are allowed again. The stepper motor activates, turns the body, but in between those stepper pulses, the computational program is getting updated input. The last two functions work to create a dead zone so that when the windmill blade assembly is essentially centered and thus fully faced into the wind, the motor can turn off. Keeps the heat down, lowers the amount of battery usage, as well as cuts down on mechanically induced stutter. Now for a demonstration of the unit's function. Turn it on. Now I'm going to push against the blade assembly. The unit turns in order to relieve that pressure. Whenever the blade assembly is centered, the unit stops turning. Now for some wind. As the wind pushes on the blade assembly, if it's off-center, it's going to have more tilt to one side or the other. So the Arduino is going to turn the body to center that tilt. Now as I turn the entire unit, again that induces uneven pressure, the body turns to accommodate it, attempting to keep the blade assembly directly face onto the wind at all times. This concludes my presentation. Thank you for watching.